So once again, ladies and gentlemen, I want to welcome all of you to the Valley of the Shadows of Management Science. Remember, Alexander Pope III, he said that a little learning is a dangerous thing. Okay? A little, if you want to do something, do it big. Yeah, Samuel.
No, please, I joined late, but I wanted to find out if I'm in the right place.
This is management science.
Yes, from the timetable, health services management, we have management science from 10 to 12:25.
Yeah, this is 10.
But
no, it's not.
We are almost 2. It's around 2. So I don't know if that's the same program.
I finished that one already. I have finished that one already.
Oh, okay. We were looking for the page to join, but unfortunately, it wasn't given to us that time.
Sorry. So you can stay with this if you can. And by the way, there's a group created. Okay, there's a group I've created. You should join that group because they have all the information going on there. In case you don't know about the group, I can put the group right here so that you can join the group. I think I did put here, right?
All right. If I could get it, please.
This is a group. I've just put it in the chat here. Just join the group. Yeah. All right.
Thank you.
Subscribe to the YouTube channel. Increase my algorithms. Okay. Let me get more paid and enjoy the knowledge from there. Stay alert when you are in the class, and please write everything, especially with those things I will say. Write everything. It will help you. There are two groups of people right here. Okay. Some will lower your hands. There are two groups of people: those who are hearing me and those who are listening to me. Hearing is physiological. Listening is psychological. Listen. Don't hear me. Okay. That's key. I want to just move on. And now go and begin management science. What is management science? What is management? Write everything down. Management science is also called operations research. Management science is also called operations research. And this is why you got to be writing as much notes as you can. Your book must be management. Don't have a book that is less than 50 pages. Have a book that is more than even 100 pages. Because you'll be writing so many things. That book is going to be a lie. Management science is a combination of mathematics and quantitative analytics for solving business problems and making business decisions or managerial decisions. That is management science. Management science is a mathematical and a quantitative approach for solving business problems and making managerial decisions. So we don't just use hindsight. We don't use insight. We don't use oversight. We don't use which other one? Hindsight, insight, oversight. Oh, there's another one. Foresight. We don't use any of these. A bit of foresight, though, because we look at forecasting. But you need a lot of quantitative algorithms to be able to help you to be able to address real situations. Sometimes there's a modicum of computer science as well. Ladies and gentlemen, there is mathematical grounding in management science. And I support you along the line. And that's also why I've given you Aquila. Please go and study the following topics in Aquila before next time. There are 4 main topics in Aquila you should go and study. That's why I've given you the book. Number 1, study equations and simultaneous equations. The word problems. Study equations and simultaneous equations word problem. And then study vectors and matrices. Study vectors and matrices. Okay, these are foundational. Look at them. Look at them. Look at them. In fact, go and ask your baby sister or your baby brother to teach you, and that you have gotten to their level. All right. So management science, where did it begin? Where did it start? After the Second World War, something happened. The British and the American militaries, they used management. Well, at that time, it wasn't called management. It was operations research strategies to defeat the Germans. So most of the strategy, tactics for defeating the Germans in the war were operations research tools. After the war, these were contained into several areas of life. So after the war, it went into engineering, it went into finance, it went into transport, health, businesses, marketing, telecom, so all of those things. The strategies elevated into several things. Yes, I want you to pay attention to me, because usually this is the time people like sleeping. This is a time after lunch, people's eyes are gulping and at the same time closing at the same time. So I need to wake you up sometimes. And the only way I can wake you up is by calling you and shouting and telling you that wake up. So you need to know that management science started coming from the war, and then it went into computer science, statistics, and mathematics as operations research. But it started going into our area, business schools, as management science. We couldn't use the word operations research for it. We started using management science. Guys, it's a science. It's not management, oh, it's a science. It's not management. You see the way management, no, it's a science. It's mathematical science. And that is what you want to have in mind. I quite remember one guy said that, oh, but this one is management. It's not management. It's not management. It's mathematical tools which managers are learning. It's mathematical tools which managers are learning. So that's management science. Now let's look at the techniques. The techniques of management science. There are some techniques you will use, okay, for this course. Number one, mathematical programming. You will use that. I will use the first 1 month to teach you mathematical programming. But if you look down here, not all of this am I going to teach you. I will not teach you. In fact, the first 5, I'll teach you. I will not teach you duality. I'll teach you linear programming, sensitivity, transportation, assignment, transshipment. I'll teach you all. I will not teach you dynamic, but I'll teach you integer programming. I will not teach you nonlinear or goal or stochastic programming. I will not teach you. I will not teach you semi-definite or definite programming. I will not teach you. I will not teach you conic programming. I will not teach you robust optimization or convex optimization. I will not teach you. So don't worry. But I'll teach you deterministic inventory models. I'll teach you forecasting. I'll teach you queuing models. I'll teach you network models. I'll teach you decision analysis. I will not teach you game theory. I will not teach you simulation. I will not teach you Markov chain, but I'll teach you probabilistic models. Welcome. Welcome to Management Science. And so that you sign up for this. Yes, Pearl.
Hello, thank you, Doc. Doc, why is it that you are being selective with these courses?
Because some of them are so advanced that if I start teaching you, there might be ambulance. Please, have I answered your question? Come see.
Yes, Doc.
I didn't ask you to answer that question. That is the only answer to that question. Yes, Stanley.
Yeah, we know how difficult it will be, and then we signed up. So if you are being selective,
no, be very real. Be very low. You don't know. The thing is that the nature of the program is in such a way that I will not even be able to complete teaching you all of it, even if I decide to, because the semester is short. It will require 2 semesters, first of all. But we can't do it 2 semesters. Let's go on. Let's go on. So, look, by the time I finish the first one, you would have, that's the most important, you would have understood the foundation. Okay? And if you want to do PhD, then come and do PhD in management science in the OMIS department. That is when I'll teach you all of this. So come there. I'm the head of PhD in management science, so you don't have a problem there. I'll guide you to do your PhD in management science. That's a very beautiful area. Because please remember, you can apply all of these things in marketing, in engineering, in finance, in HR. You can apply it in everywhere. Now let's look at some of the things management science can help you address. Sarah.
Yes, well, thank you so much. Please, I want to find out, I don't know if it was shared earlier, the course outline, so that we can also know how we will try and learn the things that you are taking out.
Guys, on the page, have you joined the page? If you have joined the page, somebody will just forward it to you. Looks like those who are on the page are not helping at all. So let me just, how can some of you be on the page at all? You're not helping your police. You need the thing. I've just posted it there for you, okay, so you can see it. Are you on the page? Sorry, are you on the page?
Yes, please, I am. Yes.
It. You see it there right now. All right.
Okay, thank you very much.
How do you compete? How do you compete? Which is the most competitive bank? Somebody said it's EcoBank. Really? Okay. How can GCB Bank effectively compete against EcoBank? Management science can easily help you. Simple. How do you decide ahead of time in the midst of COVID, in the midst of uncertainties, what to produce and what to charge? Management science can do that. You have a lot of people working. They don't even know what to do. How do you assign tasks, schedule tasks, manage resources so that everybody knows exactly what to do, when to do, and how to do? Management science can do that. Have you ever been to the church or Wache joint where there's a huge queue there? And then you want to reduce the queue. Do you know the mathematical model that can be used to reduce the queues? Management science can easily do that. Anywhere there's a queue that will build up, okay, management science can help you do that. Now, let me give you some practical things. How powerful management science is. The American airline company that we know, they use optimization, which is linear programming. The first thing I will teach you today. They use optimization and forecasting. And they were able to offer discount in revenue management. Every year, they make $1 billion incremental revenue every year. Using what? Management science. Management science is saving them $1 billion a year. Is it practical? Oh, yes. In South Africa, the Defense Force used optimization and were able to reshape the entire Defense Force and the weapon system in 1977. They were able to save $1.1 billion. What helped them? Management science. Now let's calm down. Let's say that you want to go to London and you want to search for the cheapest fare. You type it into Google. Google takes you to Skyscanner. Skyscanner will now use an algorithm which has already been developed by management scientists. And this algorithm, okay, will search among the millions of options and will get you the cheapest fare. That's management science. They use an algorithm that is an optimization. I'll start teaching you that today. Now, another algorithm will schedule the flight crews and the aircraft. If you get to London, you will take a London cab. The moment you enter the cab, the meter will start reading. Management science has been used to create a mathematical model that will maximize the revenue for the car rental company. Ernest, is management science practical?
Yeah, it's very practical.
It is. If you have knowledge and skills on how to develop models on management science, you become one of the, senior members of your company. Guaranteed. But you must have knowledge on how to what? Convert things from mere situations to management science models. You got to simplify things from sophisticated environment. Leonardo da Vinci said that simplicity is the ultimate sophistication. If you want to be so complex, try and be too simple. And management science helps you because you develop models. What is a model? You can tell me. What is a model? What is a model? Did I tell you that I give maths in class? Yes, Pearl.
Okay, so
Hold
mine
on,
is the
hold on,
layman's point
hold
of
on.
definition. Model is a type of operational operational method or tool that a company uses to operate, if I should put it that way.
Okay, is a class shop here? Class shop right here.
Yes, I'm here, sir.
Okay, I'll be giving marks to some people that answer my questions right. And so when I mention that the person has gotten a mark or 2 marks, then you document that. Okay. The person will message, I get to know the person will message you, and then you put the name,
Right.
the marks down.
Noted, sir.
All right, Francis, what is a model? And please, nobody should be Googling things and chat GPT and Croc and DeepSeek things for me. I know all of these things, so don't use this in your learning environment. Yes, Francis.
Doc, I would say it's a framework to get things done.
Yes, you are somewhere close. You are somewhere close. What is a model? What is a model? Stanley.
Yeah, Doc, it's a simplified framework that represents a system.
All right. A model is a representation of reality. In case you don't know, document it. A model is a representation of reality. That's a model. It's better to operate a model, a small aeroplane, than to get an actual aeroplane. Okay. That's why we use models. Models are powerful. Okay. You don't need to spend a lot of time. You don't need to spend a lot of money. It's good to use models. Models are powerful. It will help you to reduce the risks. Why would I want to use a huge aeroplane to prove the power of the avionics when I can use a model of that? That's why we develop models. Now, let me ask you a question. You all know about selfie, right? Philippa, you know selfie. You've been using it, haven't you?
Yes, please.
Yeah. Is a selfie a model?
Yes, please.
Why?
It's more of a representation of myself, just a small frame of me before you would get to see the whole person.
Exactly. Exactly. You're right. A selfie is a model. You can manipulate that selfie than to actually manipulate yourself. So sometimes in movies, we use a lot of models. Okay. You all know Ben South. Ben South was asking a question as to whether he actually kissed a girl. He said, no, they put his mouth and then they put the mouth of the girl. And they use AI to join the two. A model. A model. So we use models a lot. So now we are going to look at the first technique of management science called linear programming. Yes, tell them.
Say, I wanted to find out, per your definition, what's the relationship between a model and a prototype?
Oh, it's similar. Prototype is slightly more advanced, but then it's basically the same thing.
Okay, thank you.
All right, so the word linear programming. Linear comes from which word? Which word? Raise your hand. Yasmin. Yasin.
A straight line.
Straight line. Very good. I love that part. I like the straight part you added. A straight line. Ladies and gentlemen, this word, I'll be using it a lot. It's known as LPP. LPP. What do you think is the meaning of that word? LPP. Brenda.
Yeah, please, I think it's linear programming problem.
Excellent. Very good. 1 mark for you. Remember to let them know. Okay. So guys, in case you don't know, write it down. Write it down. This is where you write things down you don't know. LPP means linear programming problem. So what is a linear programming problem? It's a mathematical model that uses lines to help managers decide ahead of time in an optimization model. Linear programming. You can use it in media selection. You can use it in scheduling, in management, financial planning, capital budgeting, investment, production, transportation, assignment, so many things, even in network models. Linear programming. It started somewhere in 1939 by Kantorovich. He began the idea. But it wasn't really proper until Danzig in 1945 brought it up. In 1948, Koopmans coined the term linear programming. By the way, most of them, these guys are all Nobel Prize winners. Kantorovich and Koopmans, they shared the 1975 Nobel Prize in economics. So that should tell you how powerful it is. But after 1945, it was Danzig, who everybody normally remember. Why? Because he developed something called the simplex algorithm. Write it down. Simplex algorithm. What is an algorithm? Don't YouTube or Google things. Use your mind always. The human mind is more powerful than the computer. Yes, Kofi?
An algorithm is a set of instructions or rules that can be followed to reach a particular result.
Very good. Excellent. 2 marks. Remember to collect it on the classroom. So an algorithm is a step-by-step procedure for achieving something. Fix this one first. You don't want to get a manual, okay? And they tell you that do this one first. If you go and do the first one last, you're in trouble. By the time you finish, you see that the face has become the back and the back has become the face. You got to follow the procedure. Now, he developed an algorithm called the simplex algorithm. Now, this simplex algorithm is the same thing the Excel uses. We shall use Excel in 2 weeks. And the Excel will use this simplex algorithm. At the master's level, the MPhil guys, I teach them the step-by-step process of the simplex algorithm. But you people, I will not bore you much with that. So that is linear programming, a bit of history about linear programming. Now we're about to do linear programming. And the most important thing I want you to pay attention is what I'm about to show you. What are the components of the linear programming problem? Write it down. Components. Now, first of all, I want you to know that there is a problem. The problem must be converted into a linear programming problem. I want to repeat that. It can be life's problem, but you got to convert and rewrite the problem as a linear programming problem, which means there must be numbers, and it must be possible to linearize to come out with a line from the problem. From the problem, you should be able to design lines. So it's not every problem that is a linear programming problem. But you can convert some problems into linear programming problems. About cooking, about marriage, about worship, about so many problems, you can convert them, giving numerical values, into a linear programming problem. In that problem, there are 3 things you got to know. Number 1, the first thing about a linear programming problem is that it must have a decision variable. Write it down. Decision variable. What is that? The decision variable, or the decision variables, plural, these are the problem solution, the solution to the linear programming problem that can help you to achieve the objective. Write it down. The solution to the LPP that can help you to achieve the objective. That is the decision variable. Guys, you must understand the decision variable so well, because the next 1 month you're going to be dealing with it. I'll give you an example. If you are going from Accra to Kumasi to which is more important? Philippa.
The wedding.
Why?
Because I need to get to the wedding and I need transportation. And the Lamborghini is a mode of transportation to get me to the wedding.
And what if the Lamborghini is not there?
Then I would have to get other means to get there.
Exactly. Now watch this. The decision variables are the means to arriving at the objective. Yes, Hakim. The decision variables are the means to arriving at the objective. So first of all, you got to know that the decision variable is the most important thing you got to find. Now watch it. They are the things you got to find before you can arrive at the objective. They are the solutions to the problem. They are the solutions to the problem. Take note. The second thing is objective itself. Now watch it. The objective is something that is the goal.
Yes.
So the objective here is the wedding.
Yes.
That's objective. It's a wedding. In monetary terms, the objective can be a cost. It can be profit. It can be revenue. Monetary terms. It can be salary. And your goal is to maximize objective or minimize objective. Watch it. You maximize or minimize objective. You maximize or minimize objective. You maximize or minimize objective. But it is not always supposed to be monetary. I'm going to ask you to give me quite a number of them. In the previous class, they gave me some strange ones. So there are certain things your goal is to maximize. Give me something that, and please, it has to be quantitative, okay? Yeah, think about it in a quantitative term. Give me something that is quantitative that you can maximize that is not monetary. I'll give you an example. A typical example are the audience in a theater. So when Uncle Bo White does his program, his goal is to maximize the number of people that will come. So he does a lot of exposure advertisement for so many people to come, not necessarily for the profit, but to get the audience. The goal is to get the audience. So that audience can be maximized. You can maximize the number of audience in a theater. What else can you maximize? Don't worry, if you are wrong, I'll tell you you are wrong. What else can you maximize? Sarah.
Yes, Prof, please. You can also maximize the number of people using a particular application, maybe a software app.
Using what?
Or like your user. I'm talking about the number of people using a particular application.
Why? Why would you want to maximize that? Be specific.
So, for instance, the application provides a particular service. Let's say an application that helps users, for example, like the Uber app. You know, you want to maximize the number of people that is using this particular app.
Good. See, when you make things simplified, or you do a simple example, it makes sense than generalizing it. Very good. Okay. So app users, the Uber app service. Very good. That is one mark. What else? Kofi?
You can maximize space or the use of space. So, for example, you are organizing an event, and the space that you get for that event, you can maximize it to such a way that you can accommodate more people in the room.
Yeah, but you can also such a way that you don't want overcrowding, so you can minimize the people coming.
Yes, please. So space.
No, I won't buy that. I want maximize alone, not possibility of minimizing it as well.
Okay, then time.
Please don't be doing lottery. You go and think about something, or you come back again. Okay? Otherwise, when I do this, you say this. I'll see this. Come back again. Solomon.
Yes, sir. You can maximize the number of people occupying, let's say, hotel rooms, for instance.
Okay. Yeah, it makes sense. In other words, you want more people to come and use the hotel. Yeah.
Yes, please.
Very good. Very good. That's a mark. David, give me one.
Prof, you can maximize customers.
That's too general. Come on. Everything here you are talking about is customers. Let's go to
You can also maximize your network.
Come back again. Come back again.
Number of students in a class.
Who is talking? Who is talking? I don't even know who is talking now. Have I called the person? Ernest, go ahead.
Prof,
yes,
you can maximize the number of
who is
YouTube
talking?
views.
Who is talking?
Dennis.
Dennis, have I called you?
Okay.
Please, we are in a coordinated, maximized environment. Ernest.
Yes, Doc, you can maximize the yield of crops. Maybe you want more crops.
Very good. Excellent. I love that. No question about it. That is a mark. Very good. Randolph.
Yes, sir. So he just said mine, but let me attempt.
It's okay. Oh, you have another one.
You can maximize your market share.
Very good. You can maximize your market share. Excellent. That's a mark. Let's go to Daisy Lane.
Yes, you can maximize in a example as a bank, you can maximize how many accounts you open in a day.
Very good. You can maximize the number of accounts because you have a target to get a certain number of money. Very good. That's a mark. Hakim. Philippa.
Hello, Doc.
Yes.
Yeah, this is Akib. Doc, can you say you can maximize the spectators at a stadium?
Very good. Maximize spectators at the stadium. Excellent. That is a mark. Grace. Your hands, all of your hands should be on.
Good afternoon. So you can maximize the reach of news. So using social media, traditional media to maximize
Very
the
good.
reach.
Excellent. Excellent. You can maximize the reach of news. Hamidu.
Okay, so I think you can maximize your health by increasing the number the time you sleep, by exercising also, and then all those physical things to
How do you
increase.
quantify that? How do you quantify what you're talking about?
I mean, when you are having, let's say, you are increasing your hours of sleep from 5 hours to 7 hours of restful sleep. You are having an average brand minutes or like hours so that you increase your health and well-being.
That's all you need. So you are picking on each one of them and then putting it together. You are picking the hours.
I can't hear you. Can you come again, sir?
What I mean is that you are picking the hours of sleep, then you are picking the exercise, and you are picking other things and putting it together to indicate health. Is that what you mean?
Yes, please. Yes, please. The hours of restful sleep. The average.
Good. That's okay. That's good. That's good. Let me take two more. Isa or Hassan? Hassan.
Yes, Doc. So please, we can maximize the number of people that test for a particular disease, like during the COVID time, like the government.
You can maximize what?
The number of people that test, that do a test, like lab tests for a particular disease.
Okay. Number of people that test for a particular disease. Yeah, you can. In other words, you want more people to test. That's what you mean.
Yes, so that you can contain it. You know the number of people having that disease.
I love that. I love that. That's good. That's good. That's excellent. Excellent. Let's go to Sawyer. Karen.
Hello, sir. I'm thinking you can maximize the number of views you have on the streaming platform or on YouTube.
The number of what?
The number of views that you have on a streaming platform or on YouTube.
I think somebody has said that already. Somebody has said
I
that.
think the person said apps on apps.
Yeah. So you know what the person said? They are saying something similar.
I already had this point here. Okay. But
I
yeah,
was going to
similar.
end with you. I was going to end this whole maximized thing with you. All right. So that is fine for 1 mark for that. That is fine. So the objective has to be precise. That's the key thing. The objective has to be precise. That is the next thing. Then the final thing is a constraint. The constraints are the very limitations, okay? Things that you would need the availability before you can achieve. Guys, the best way to explain linear programming to you is to use a simple example. And so I'm going to take a simple example. We're going to walk ourselves through this simple example. At this stage, you want to pay more attention on how to go about linear programming. I need somebody to read the storyline because you're going to use this story to understand everything. Who will read for us? Who will read? Those of you whose hands are up, you should lower your hands if you're not ready to read, so that I'll call only those that are going to read. Who will read for us? Laurentia.
Okay, so example 1. Fan Milk Ghana Limited produces Fan Yogo and Fan Choco. Some Ghanaians love these. I don't know about you. The 2 key resources used by the company are milk and skilled labor. Given the limited resources, the company desires to know how many sachets of Fan Yogo and Fan Choco to produce each day in order to maximize profits. There are 40 hours of labor and 120 gallons of milk available each day for production.
Continue.
Fan Yogo requires 1 hour of labor time, and Fan Choco requires 2 hours. Also, Fan Yogo requires 4 gallons of milk, whilst Fan Choco requires 3 gallons. The profit from a sachet of Fan Yogo is 40 Ghana cedis per unit, and from Fan Choco is 50 Ghana cedis per unit. Formulate a linear programming model for this product mix problem and solve using graphical analysis.
Thank you. This is an IE exam. This is an interim exam. So I'm going to walk you through this. And in the process, of course, I will explain. Guys, if you can understand this, you have cemented your brain in the power of linear programming and all subsequent applications. It's not what we will do later that matters. This one. If you can get it, hallelujah to you. So let me ask some preliminary questions. We are looking at Fan Milk Ghana Limited. They are producing which products? Fan Yogo and Fan Choco. Now, the first step in linear programming modeling, watch it. There are 4 steps. The first step in linear programming modeling is to define the decision variables. Write it down. The first step is to define the decision variables. That is step 1. Define the decision variables. Define the decision variables. What are the decision variables? Remember, we've explained what the decision variables are. In this storyline, without cheating, but based on your knowledge and the preamble we have read, what do you think are the decision variables? And remember, I asked you why you chose them. What are the decision variables? Yasin.
So the first decision variable is to determine how many or the quantity of the products to produce each day. And the end goal is for them to maximize profit. That's what I think the decision variable is.
You are near, but you are still yet so far. What are the decision variables? What are they? Let's go to the lower hand and let's go to Anaba.
Okay, so let me try.
Okay. Right. Okay, let's go to Chris Tokin.
Sorry, I think my line was cut off. Sorry.
Okay, go ahead.
Saying my decision variable will be labor, as in the input to determine the objective, which to produce fine milk or fine yogurt or fine chocolate. Thank you.
When you look at the story your friend read, that is not correct. So let's go to another person. Let's go to Ibrahim Bawa. What are the decision variables in this Farmer Ghana Limited story?
Okay, thank you, sir. I think there are 40 hours of labor and then 120 gallons of milk.
Very good. That is incorrect. Okay. That is not the decision variables. Let's go to another person there. Radio, John.
Doc, I was about to lower my hand because I also think
it's okay, no problem.
Odro. Gallons of milk. So.
It's okay, Odro.
We want to know how many sachets of fine yogurt and fine chocolate to produce each day.
So what are the decision variables, Odro?
It will be the number of fine yogurt and the number of fine chocolate.
Excellent. That's it. Guys, if you can identify the decision variable, 40% of your work is done in linear programming. So how do you identify the decision variable? I told you earlier that the decision variable are going to be the solution to the problem that you need to achieve the objective. I also told you that the decision variables are the items you are looking for, the things you are looking for, the things you are going to produce, the audiences you are going to maximize, the items that you are looking for. Now, from the question, you will always be given a kind of a clue to know. Towards the end, it says formulate a linear programming model for this product mix problem. So product. What product? Fan Yogo, Fan Choco. So now you know that the products are Fan Yogo and Fan Choco, but what is the decision variable? The decision variable is not that we don't know that we are going to produce Fan Yogo. No, we know. It's not that we don't know that we are going to produce Fan Choco. We know. That one we know. But why do we have to decide on it? Why is it a decision variable? It's a decision variable because we don't know the quantity we are going to produce to maximize the profit. We don't know. We don't know the quantity. We got to make a decision and know the number of quantity. In this case, the quantity was in the form of a unit of measurement. The unit of measurement for Fan Yogo and Fan Choco is what? You can tell me. What was the unit of measurement here? Hell.
Hello, Doc.
Yeah.
I wanted to ask a question, but not the answer you are asking.
Right.
Okay, so even though you said the problem is the number of Fan Yogo and Fan Choco, for me, I thought it was going to be the customers because we will have to consider the customers.
No customers was mentioned here.
Sorry?
No customer was mentioned here. No, the word customers was never used here.
Okay.
See, that's why I said.
I was thinking, it's not like it's being meant, but I was thinking because it says some Ghanaians love this. So if some Ghanaians, we are looking at the customers.
Yeah, but there was no data on customer. Remember, this is a linear programming. We must have data on what we are going to handle.
Okay, all right. Thank you very much for the clarification.
Yeah, so when you have a decision to make, it's because there are some numbers. So you should use the numbers to make a decision. And in this context, you have been given some numbers. And in fact, there's always something that will help you to know. Watch it. It will tell you where the problem is. It says that given the limited resources, the company desires to know. Watch that sentence. How many? They desire to know. You don't know. And decision variables are things you don't know. Write it down. The decision variables are things you don't know. And when I say things you don't know, I don't mean that we don't know that we are going to produce fine yogurt. No, that one we know. Not that we don't know that we are going to produce fine choco. No, that one we know. But what don't we know? Who can tell us? Repetition for emphasis. What don't we know? What don't we know? And that we are discussing, Laurentia.
We don't know the number of sachets of fine yogurt to produce as well as fine chocolate.
Exactly. That's 1 mark for that. Take note. We don't know the number of sachets. We know we are going to produce it. That one we know. But we don't know the number of sachets that we are going to produce. Write this down. Always remember the unit of measurement for the decision variables and add it. The unit of measurement of the decision variables. Always remember to add it. That is a decision variable. If you don't have a question, please lower your hand. Okay. So, in linear programming, remember we're going to mathematical model. And because you are going to mathematical model, you got to be able to now know clearly, know how you are going to represent this in a mathematical framework. So how do you define the decision variable? You always have to say something like let, and then you represent each decision variable by an X. If the decision variables are 10, you should have X1, X2, X3, all the way to X10. If the decision variable are 20, you should have X1, X2, all the way to X20. Now, in this case, we are going to have up to X what? Daisy.
Thank you. I have a question actually.
Go ahead.
To answer a question, you'll have just two. That's X1 and X2.
Okay.
My question is, do all decision variables have units of measurement?
Yes. And even if they don't make that explicit, the unit of measurement will be number of. They all have.
Okay, thanks very much.
Number of. So, going back to your point, the decision variable is going to be X1. We are going to define it, then X2. So X1 should be something, and X2 should be something. We'll come to that. But Susie, do you have a question?
Yes, but I was hoping that your further explanation should clear my doubts, because from the first example you gave when you were explaining decision variables, where you use the wording as an example, where you use your a car to go to the wedding, or a different means of transport. You describe the means of transport as the decision variable. So in the question that you gave right now, I was thinking the milk and then the skilled labor will be a decision variable. But as you go further, I'm hoping to understand you better.
So the decision variables are the items you are going to produce. They are the customers you are going to sell to. They are the bags you are going to procure. Yeah. They are things you are going to get. Its number you don't know. So when you take something like labor, we know the number of labor here. We have 40 hours of labor. So we have 120 gallons of milk. We know that. But then we don't know how many sachets. We don't know that. That is a decision variable. And the decision variables are always supposed to be produced or something that you want to manifest. You want to bring it to light. These are the terms you should write down. It will help all of you to know when to look for the decision variable. All right.
Okay.
I hope that hand is handled. All right. So let's go to the definition of the decision variable. How do you define it? You will say that let X1 be something. This is how you put it. Let X1 be the number of, and you must always write it in English, number of sachets. In this case, we know the unit of measurement. So the number of sachets of fine yogurt to produce. That's how you define the decision variables. Number of sachets of fine yogurt to produce. You should write it in full sentence. What do you think will be the way to define the X2? You can tell me, how do you define the X2? Amidi.
So X2 will be the number of sachet for fan choco to produce.
Very good. Remember that if you ever write the decision variable without the unit of measurement, you're wrong. Keep that in mind, you're wrong. So if you just say fan yogo, you're failed. So it's always good to indicate together and indicate that whether you're producing it or you are investing in them or you are selling them or whatever you're doing them, that verb, you should still bring the number of, in this case, sachets. If it is not, suppose we are talking about audience, you will not say number of sachets of audience. Okay. So let's say you're talking about a stadium and we have some people at the VIP, some people at the popular stand, some people at the normal stand. You will say that number of spectators at the VIP, number of spectators at the popular stand, number of spectators at the normal stand. That's how you put it. That is critical. Without the decision variable, you have no story. Done. Who is not clear? Excellent. Let's go to step 2 after the definition of the decision variable. The step 2 is formulate the objective function. Formulate the objective function. That is step 2. Now, first of all, what is objective function? The objective function is what we call the goal. It is always represented by the letter Z. The letter Z. It is that thing which we are maximizing or minimizing. It is that thing we are maximizing or minimizing. In our example here, which one is objective function? Are we maximizing or we are minimizing? Yes, Asiasibe. Are we maximizing or minimizing? Ernest.
We want to maximize profits.
Very good. So now we know that we are maximizing. Now watch this, watch this. Because we are maximizing, you must always bring small max down here. After the Z, you add max to indicate that we are maximizing. But before I give you for this example of Farmer Ghana Limited, I want to give you a general way of writing the objective function. A general. You write objective function as equal to, watch it, Ci, Xi. Now, what is a Ci? The Ci is the coefficient of the decision variable. I've not finished, but let me just write it all first. Then you bring in front of it the summation sign, this big summation sign. And then you will write where I starts from 1. I starts from 1 all the way to K. This is a mathematical way of writing things. I starts from 1 all the way to K. Now, if I want to make it clear for you to see, I can say that this is the same as saying C1 X1 plus C2 X2 plus C3 X3, which goes all the way to CKXK. Okay, it goes all the way to CKXK. But let me explain what this means. Guys, you are modeling, no. You are modeling, answer. You have no choice. You are modeling. You are modeling. Yeah. You are welcome. You are welcome. You are modeling. You have no choice but to learn how to model. Okay. So let me take this off. Let me take all of this off and explain something. This is a general. When I say general, it means I can apply to anything. That's what it means. Okay? So let me just take this off. Let's take the general one. This is a general one. So what it's saying is that the Z, which might be profit in our case, is the value of the CI. The C is the coefficient of the decision variable. Another name is the marginal contribution of the decision variable. Write all of these things down. The C is the marginal contribution or the coefficient of the decision variable or the profit contribution of the decision variable. So what does that mean? It is actually telling you the value of the decision variable, the price attached to that decision variable. So if the decision variable is this cap, what is the price of this cap? What is the profit of this cap? What is the value attached to this cap? That is the C. Sometimes it's a cost. So if it is a cost, what is the cost of this cap? What is it? It can be a cost, or it can be a profit, or it can be a revenue, or it can be an audience, or it can be anything. So each of the decision variables, X1 will have its own C, X2 will have its own C, X3 will have its own C. Each one of them will have their own C. When you put them all together, that is where you have the summation sign. So this summation symbol indicates that as many decision variables as you have. So if the decision variables are 20, what is the value of K? What's the value of K? Hafsa?
20.
It's also 20. Okay, so the K will represent the total number of decision variables. So you will have K representing 20, or 20 representing 20. So that is it. This is a general way. But I don't want the general way. In our own, we have our specific examples. So now that I've written this, I'm going to go away from here. And then I'm going to now redefine for Formulating Limited. So for Formulating Limited, we know we had X1. And we also know that we had X2. And we know that these are two decision variables that we want to combine. What was the coefficient attached to the X1? What was the marginal contribution of X1? What was the profit contribution of X1? It was actually mentioned in the story. What was the profit contribution of X1? What was the marginal contribution of X1? What was it? Davida.
Hi, sir. So X1 being fine, you go, its marginal profit will be 40 Ghana cedis per sachet.
So you have 40, and then for X2, Davida.
So for X2, the marginal profit will be 50 Ghana cedis.
So that's 50 Ghana cedis. Excellent. Excellent for 2 marks there. So guys, that is significant. So it means that the objective function is saying that 40x1 plus 50x2. That's what it's saying. Who can tell me what the 50 stands for? The 50 stands for the profit for producing one choco, one fan choco. Which means that if you are producing 2 fan choco, then the profit will be what? 100, exactly. If you are producing 20 fan choco, then the profit for producing the fan choco is what? A calculator. Pearl.
100.
100. No.
Oh, 50 by 20.
Palmer. Philippa.
1,000.
1,000. Very good. So that is how it's going to be. So now, listen carefully, guys. Who can tell me what does this mean? This stands for what? What does this stand for? This 50x2, what does it stand for? Who can tell me? I'll give you 2 marks for that, if only you can understand. What does the 50x2 stand for? Stanley.
It means the two units of the fan choco.
That is wrong. Let's go to Mgt. What does the 50x2 stand for?
That means 50 CDs per unit multiplied by the total number of.
That is wrong. I don't want what you said. Let's go to another person. Samuel, what does the 50x2 stand for?
It stands for the profits fine choco makes when they are able to use 3 gallons of 3 gallons.
Let's go to Kofi. What does it stand for?
It stands for the maximum profits that fan choco can make.
Excellent. I love that. I love the way you said it. That's 2 marks. That's 2 marks. This guy's good. These are the people you should befriend, not the one you have been befriending. You should befriend people like Kofi. Okay. It's the total profit that you can make only on fan choco alone. Total, not single profit. Total profit on all the total profit that you can make on fan choco. So what do you think is the total profit you can make on fan yogo? You can tell us. What is the total profit you can make on fan yogo? This one is cheap side. The way Ernest is smiling, there's a clear evidence of copycat. Okay. Let me give it to Ayoko. Yes, Ayoko.
Hello, sir.
Go ahead.
So 40x1.
The total.
40x1 has done what? What is that?
40x1 is the total profit you can make from fan choco.
That is not correct. That is not correct. Araba.
Yes, sir. So 40x1 is the maximum profit you can make from selling the fan yogo.
Exactly. That is 1 mark. From yogo, not choco. Okay. Not choco, as she said. It's from yogo, fan yogo. So you got to understand this is the objective function. Now, who can tell me this? What does the 40x1 plus 50x2 stand for? What does the 40x1 plus 50x2? What does it stand for? Deborah J.
It stands for the maximum profit farm milk can make when they produce their 2 products.
Excellent. Excellent. That is 2 marks. You are thinking. That's good. Okay. So when I ask you what it is, you don't say that, oh, but we don't know what the 2 products are. The 2 products we don't know. We don't know the profit they are making. We know the profit is 40x1 plus 50x2. That's all we know. Excellent. So we've been able to finish step 2. Step 2 was formulating the objective function. Let's go to step 3. Step 3.
So, Doc.
Yep.
I want to ask a question. So what will be the formula if we want to look at the minimum profit?
We can't know the minimum profit because they can make 0 profit.
Okay.
They can make 0 profit. Who can tell me why they can make 0 profit? I know we haven't gotten there. But don't worry, I'll come back to that. Oh, but let me see whether somebody can tell me. You can tell me why they can make 0 profit. Let's see. Sometimes there are some creme de la cremes among the class. It's not everybody who is like everybody. Let's go to Samuel Bauer. Are you with us? Have you raised your hand or you from the previous? I know you haven't raised your hand. Hey, Hamza, you want to go? Go and let's see.
So I am saying the thing is, I think that they can make zero profit because production is not sales. I don't know if I make sense.
Production is not sales. In what context?
In the context that you can produce the fan chocolate and produce the fan chocolate, but what if people don't buy it? Like you've not made sales, right?
But we never spoke about sales. When we spoke about profit,
that's why I said
production and sales are equated here. Let me get one more. I know it's a difficult question, but I thought somebody would crack it. So let's see. I don't want guesses. If you know you're guessing, lower your hand. Okay. If you get it wrong, -2. That will help you not to guess. I'm going to say your hands will still clear. If I call you and you get it wrong, -2. -2. Okay. I want to fail you then and tell me that the marks you haven't even gotten some, and I'm now reducing 2 from it. Yeah, imagine. CKUM.
Thank you, Prof, for this opportunity.
It's not an opportunity, it's your own.
Okay. A business entity can easily make a zero profit. Why? Because they've been able to break even. Neither do they lose or make profit.
No. There's no break-even point here.
So what I mean is, with the intention of a future.
Yes, we are talking linear programming. You people are bringing your real situation into the picture.
Then sorry, Prof.
There's no sorry. You have -2. Give your name. Class rep. Document his name. What's your name?
Yeah, I'm Cletus Kuhn, Prof. Prof, yes. Can I
Put
proceed?
-2 there first, and then we'll talk later.
Okay, thank you, Prof. Sorry for that.
The rest of you, lower your hand before we continue. I told you that let's move on. Now you want to still answer the question. What is all this wahala? Let's move on.
I want to answer.
Don't answer. Master, you've not even got the marks. Don't answer. Your standing is not grounded. So when you are grounded with some mark, then we can get something to differentiate. The next step is to formulate the constraint.
Maybe high cost or maybe low sales or the produce market.
Are you saying the answer so that I will start giving you minus?
So I am suggesting I am saying high cost or maybe low sales can also result in something like that.
Are you answering for math or for what? It's okay. I know. I say it's okay.
I'm answering. I'm answering. I'm sure of the answer.
Okay. Class rep, can you write Samingo Papa's name down? What's your full name?
Samuel Terry, sir.
Class rep, can you notice that down? And be ready to make it plus
okay, sir.
-2. Okay. Yes.
Okay, sir.
Masa, go on and let's see whether you can crack the code.
Okay, sir. So we wrote an objective function and we saw coefficients and with the decision variable. So because they are not constant and they are coefficients, so it means that the decision variables, if we get 0 in them, for example, we have 40x1. If x1 tends to be 0 and x2 also tends to be 0, that means that the answer will be 0. So we will not make profit.
And when are they 0?
Okay, in the specific one that we wrote, if we want to say specific to that one, they will be 0 when they don't get produced.
I know. And I'm saying, when are they 0?
I'm saying that for these ones, they will be, because
Prof, if I may bail him out.
Don't bail him.
Because we said number produced, so it will be 0 when no number gets produced. So
marking him down, I'm not marking him down. Now he has leveled the playing field. I just want to now give him the 2 marks. But for that to happen, he needs to answer that question without repeating what he has already said, which I know he has already said. We are talking about Farmer Ghana Limited. My question to you was, when are they 0?
So when they can be zero when, for example, there's no availability of the milk and the things that will go into the production. We don't get them to do the production.
Oh, they can still be available. They can still, the things that go into them can still be available and it can be zero. So my question still is, when are they zero?
When the cost outruns the...
Nothing to do with cost. When can they be zero?
When they are not produced.
So at this point, I need bail.
Okay, so somebody can bail him, but you will not get any negative, you will not get any positive. Yes, you can tell us.
Okay, so Prof, profits can be zero when all elements of production are off or there's no production.
Master, we've already listened to the guy, so make life simple for us. When are they zero?
Profit is zero when there's no production.
When there is no production, that's it. Okay. When there's no production, that is when the profit is zero. This is practical. But you yourself, you are already saying that when
I said when they don't get produced, that was my first answer.
So you remember the first answer, but not the last one. So why don't you repeat that same thing? All right, let's move on. So the next one is the constraint. Now, to do the constraint, you need to remember 3 levels of things. First, you need to know that we are dealing with usage on the left-hand side. Okay. And then you have sign in the middle, and then you have available on the right-hand side. This is a constraint. This is the most important part. Formulating the constraints. Now, the usage are the actual usage of the resources. So these are resources. Okay? The formulate constraint here means resource constraint. No, not resource constraint, but constraint. Now, let me just quickly mention that there are 2 kinds of constraint. One, we have resource constraint, and then we also have mixed constraint. The resource constraint has to do with the resources, how limited they are. So for hours of labor and for gallons of milk, they might be limited. So what they will use will be different from what is available. And then the mixed constraint, write this down because the mixed constraint is very abstract and sometimes people confuse. The mixed constraint is a mixture, it's a combination of the decision variables. It's a constraint that uses combinations of the decision variables. It's a constraint, mixed constraint is a constraint that uses combinations of decision variables without any resource. Without any resource. All right. Now, let's go back here. The usage is also the left-hand side of the constraint. And then we have a symbol, which we are going to talk about soon. And then we have the right-hand side of the constraint. Yes, Yasmin. Yasmin.
Please, can you take the mixed constraints again? Because
the mixed constraints are constraints that combines the decision variables without any resources in mind. Without any resources in mind. When we come to the resources, you're about to see very soon, so don't worry. All right, so let's go to the left-hand side. All of these are constraints, but in this very example, there was no mixed constraint. And you see that very soon. There was no mixed constraint in this very example. All the constraints that were given were resource constraints. What was the first resource? Labor. What was the second resource? Milk. So the resource constraints were the only one. So let's first talk about labor constraint. Let's talk about labor constraint. Please note that in the labor constraint, we are going to look at the left-hand side, the symbol, and the right-hand side. Now, there are 6 symbols you can use. You can use less than, or you can use the other ones, and you can use it. What's the opposite of less than? What's the opposite of less than? What's the opposite of less than? Raise your hand. Whatever is in your head is wrong, by the way. Whatever is in your head is wrong. So before you think about and say what you are in your head, remember that is wrong and change it. So what is the opposite of less than? Mercy.
Greater than.
Greater than is wrong. The opposite of less than is greater or equal to. What is the opposite of greater than? John.
No, less or equal to.
Now you get it. Okay. The opposite is less or equal to. Go and find out why. I'm not talking about English opposite. I'm talking about mathematics and statistics opposite. That's different from what you do. And of course, what is opposite of not equal to? Equal to. So these are the symbols that you can use for here. Okay. Now the question is that for labor, okay, what was the right hand side? What is the right hand side is available? According to the question, there was the use of the word available. It's right here. So what is the right hand side? Value for labor. So let's say the right hand side is going to be here. It's going to be in hours, of course. What is the right hand side? Value for labor. That is available labor. What was it? In the story. Kelvin. The
40 hours.
It's 40. Okay, very good. So you have 40 hours. Now, what symbol are we going to use? What symbol are we going to use? Out of these 6, what symbol are we going to use? And of course, you got to give me a reason, because when you just tell me the symbol without reason, it means you guessed. So what symbol are we going to use? Stanley.
Yeah, Doc, we're going to use the greater than or equal to.
Why?
Because currently they are using 40 hours and now they want to produce more.
Okay, that's wrong.
Oh.
Mama.
Doc, is less or equal to?
Why?
Because the statement said that there are 40 hours of labor available. So they can't have more than 40 hours.
But they can have what?
Less than 40 hours.
Or what?
Or equal to 40 hours maximum.
Excellent. I'll give you 2 marks for that. That's a thinking well. Okay. So the 40 hours is the maximum. So that's the maximum hours available. You can't use more than one. I mean, look at every week. Every week you go to work for 40 hours. You can't use more than 40 hours. Well, principally, you can't, even though you will work overtime, but on paper, you can't. And so that is why this is 40. Now, why is it less than? Okay, let me ask you. When you use all the 40 hours, what symbol is here? When you use all the 40 hours, what symbol is here? Kelly, Kofi.
That's equal to.
That's equal to. When you don't use all the 40 hours, what symbol is here? Jennifer.
Less than.
Less than. Okay, so what does the less than mean? What does the less than imply? And what does the equal to imply in terms of Farm Ghana Limited? In terms of managerial efficiency? What does the less than imply? What does the less than imply? What does the equal to imply? This is managerial efficiency point we are talking about. You are now thinking beyond. Philippa. Philippa. Stanley.
Yes, sir. Yes, sir. This is Philippa. Yes, sir. It implies that even if they use less than 40 hours to do the work, they will still be able to get it. And then even if they use the exact 40 hours, they will still get the work done.
No. I need one more. It's a tough question, but I still need one more. Let's go to Stanley.
Yeah, Doc, there is the less than equal to. It's like that is the maximum hours they can exceed or they can go to. So if it is less than, yeah, they need not less than 40 hours to produce the number of fan yogo or fan choco they need. And if it can be more than the number of hours to, so you have to be either less than or equal to the number of hours to produce the fan yogo.
This is managerial point I'm talking about. You are talking too much mathematics and managers are even going to be confused. Okay. I'm not going to take much. So the less than 40 means inefficiency. Less than 40 hours means the company is being inefficient because you have 40 hours to use. Resources are scarce. We've gotten the 40 hours for you. Use it all. You didn't use it all. You are using less. You're inefficient. So less than 40 hours means they are leftovers. And therefore, it means the company is inefficient. Less than 40 hours means inefficiency. Equal to 40 hours means efficiency. Note this, because there's a lot of questions on this in the exam. Okay? So it's important to capture that. Okay, now let's go to the left-hand side for the labor. Left-hand side. Yeah, go ahead.
You said if it's less than, it means they are being inefficient. But like sometimes there are cases where the company is using less than what is available, but they're able to maximize their profits. Would you still see that that's an inefficient?
There's no way. It's not possible. They could have done more. You have no document to tell me that they are using less, but they're able to maximize their profit. You have not seen the profit to see it as maximized. Okay? If we juxtapose the profit they got, even if they think it's more, they could have done more than what they did. Numerically, what you call maximum is not maximum.
Okay, thank you.
So, see, if you go ahead.
I was going to say, like, before you
give me an example for you to appreciate this point I said. You can have a football team that will go and play and they'll win 4-0, okay? But they still played less than they were supposed to play. Do you agree with that?
Yes.
They could have done more. They could have done more. They have won the game 4-0, but they could have actually had 7-0. And the coach is still not happy because he said, I know your capacity and what you could have done. You could have done more, and now you have underutilized the resources that you had on the pitch. And so, yes, they won the game, but they didn't do it to their capacity.
Yeah. And please, before you move on to the next slide, at the top, you've written usage, LHS, and then the RHS. What does that mean?
Okay, so as for the RHS on the right, that is what is here. The RHS is the right-hand side. See this symbol here? This symbol here means that anytime you are formulating the constraint, there must be a right-hand side of the constraint and a left-hand side of the constraint, which we are about to write. The right-hand side of the constraint is always available resources. That is also called the right-hand side of the constraint. So in this case, the right-hand side of the labor constraint is 40. It also happens to be the available resources or labor resources. Now we are coming to the usage. The usage actually deals with what was actually used. And in that story, we can get it by reading the storyline here. So now we're going to go down to the storyline to know what was actually used. The story told us, watch it here. It says that Fan Yogo needs 1 hour of labor and Fan Choco needs 2 hours. So how will you write that? Remember that Fan Yogo is a X1 and Fan Choco is a X2. So how will you write that mathematically here? You can tell us. Yes, Kofi.
We'll write it as 1x1 plus 2x2 is equal to 40.
Exactly. That's it. So, of course, you can remove the 1, but for now, let's bring it. So the 1x1 here means that this company for labor constraint, they are using 1 hour of labor and 2 hours of 1 hour of labor to produce Fan Yogo and 2 hours of labor to produce Fan Choco. And that should be so the whole of this thing is what we call the usage, the actual usage. That's the actual usage. That is the actual usage. Who can tell me that of the milk? Who can formulate the constraint for milk for me? You got to be incredibly smart, but you can do it. You should just first of all tell me, what symbol are we going to use? Is it less than or equal to or greater than or equal to? Daisy. Is it less than or equal to or greater than or equal to? Emmanuel.
It's less than or equal to.
Is it less than or equal to? Okay, so how is the constraint going to be? Michael Akolache. Okay, so for gallons of milk, remember the right-hand side was 120. Okay, you can see that from here. It was 120. Okay. So for gallons of milk, it's going to be 120. So let's do the 120. So you have to write 120 on the right-hand side for gallons of milk. So that is what is available now, gallons. Then what is going to be on the left-hand side, the usage. How much of these gallons of milk was used? Deborah.
4x1 for fine yogo and then 3x2 for fine choco.
Exactly. So that's it. You're done. You have been able to formulate the two constraints for labor and for milk. Now let's put all together. There is one more constraint. Let me just go here. Let's put all together and look at the final constraint. Okay. So when you come here, all of the constraints, you'll be able to picture all of them. These two constraints, that's it. Okay. You are now left with one last constraint. It is never in the story, but you must always bring it. This constraint is known as the non-negativity constraint. Write it down. The non-negativity constraint. It's automatic. It is written as x1 and then x2 must all be positive. That's it. The two of the decision variables must be non-negative, must be non-negative, must be non-negative, must be non-negative. Why? The reason is because we don't want anything that the least the company can do is to produce nothing. That's the least, that's the worst they can do. But to actually make them bring negativity, okay, that is not good. Like to go and do an illegality, that is not good. Okay. That is why. So now let's put all the formulations together. Okay. And now you have the final formulation on your screen. I want each one of you to now write this final formulation on your screen. Write it all. What have you done? You just formulated linear programming model. That is what you just did. You just did that. I didn't. Okay. For the first time in your life, you have formulated a model. We need to now solve it, but not today, another day. Because even the formulation alone has dwindled the physical size of some of you. Whatever food some of you have eaten, the food had vanished from your skin color. So there is no need to go ahead to solve this model. All man can do is what woman has done. Write this model, fill the model, understand this is a linear programming model for the product mix model. Yes, yes, sir.
Please, what does ST mean? Like it's in the formula.
Oh, subject to. So this is objective function, and objective function is always subject to this constraint. So yes, I'm going to maximize this. Oh, by the way, note that I have brought the max here, but you should always use the first one I gave you. The first one I gave you that says Z max. I use that one. And whenever you are maximizing, you bring subject to, because every goal, which is this one, every objective is subject to some constraint. And this subject to is written before we bring the constraints. Next question. What is somebody asking? If the cost exceeds the revenue, they don't make first amount. All right. Yes, Daisy.
Yes, Dr. Please, I have a question for the last formula you've written, the x1, x2 greater or equal to 0.
Yeah.
Where you said is the negativity constraint.
The non-negativity.
How do you know if a company has that?
Okay, we don't know. We are imposing it. I want to repeat. We don't know. We are imposing it. We don't want it. We are assuming the company is doing a legal thing. We don't want to assume the company is doing an illegality. So this formulation is a formulation that you are doing with assumption that the company is not doing an illegality, and therefore, because you would not normally know whether it's doing an illegality, which now brings a negativity. So the non-negativity constraint means that that company, the least it can do is to produce nothing. Because remember, the equality means that they are equal to zero. Equal to zero means that you produce nothing. Equal to zero means zero. So the least they can do is to produce nothing. The best they can do is to produce more than zero. But we don't want them to come below zero. Okay? And therefore, because why would you want to produce fine yogurt that is negative? It doesn't make sense. First of all, the least you can do with fine yogurt is to bring what is not there. But to actually not bring what is not there, but actually do something that would, hurt the company. That is not something we want. And in Excel, which we shall do in 2 weeks, in Excel, this non-negativity, you don't even write it in Excel. Excel automatically assumes that for you. Next question. Next question. So how do you solve this model? That is for another day. There are 3 ways we will solve the model. Graph, simplex algorithm, the one Danzig introduced in 1949. We shall do that. And then PC, we shall use a computer, in this case Excel, to be able to address all of that. Next question. That brings us, ladies and gentlemen, to the end of the entire caboodle. What a way to begin.